Alrighty guys, this is the Cycle 4 walkthrough. We are going to go over relative frequency tables and conditional probability. So if we go over those two definitions first, if we look, the relative frequency table, which we kind of talked about in the tutorial notes, is a chart that shows the mode or popularity of a certain type of data. And that type of data is based on the population sampled. So basically, it's a chart that displays the relative frequency. Remember, when we find that relative frequency, that's going to be the number of times a specific event occurs. And that's divided by the total number of events. So if we look at conditional probability, that is a probability that may limit the sample space. Okay, so it's a probability that has a condition that might limit the sample space. So if we look at conditional probability, sometimes the word given is often talked about. So when we get to that, I will go over more about what it means for conditional probability. So relative frequency tables can be created for three different things. It can be created for the rows in the table, the columns in the table, or for the percents. And that is using the total number. So let's go over some examples of relative frequency tables. If we look at number 1, it says 50 students in Miss Miller's algebra classes were asked what kind of ice cream they like, vanilla or chocolate, and what kind of toppings they like, sprinkles, M&Ms, or nothing. It says identify trends of the data. So that is like our conclusion. So remember, we could say something like, most people like vanilla because our total here was the biggest. Or we could say that the favorite topping is tied between M&Ms and nothing. Or you could even go a little bit further and you could state that the nothing was vanilla's favorite, and that the M&Ms was chocolate's favorite. All of these facts are trends of the data set. So that can help us identify different things about what the survey told us. So if we look at question number 2, question number 2 says to create a relative frequency two-way table for the rows. So remember, rows go across from left to right, all right? Then we need to divide each number in each row by the total in that row. So if we look, my total for vanilla was 30, and my total for chocolate was 20. And I found that from that chart, our relative frequency. We found that in our frequency table, or that two-way table in our chart on the previous page. So if we look here, we're going to let's zoom in here a little bit so we can see it better, and work our way across. So sprinkles, we had 9 votes out of the 30, and that equals 0.30. We had 7 divided by 20, which gives you 0.35. You had 8 divided by 30, which is 0.27. And you had 9 divided by 20, which gives us 0.45. So all I'm doing is I'm taking the value that was from the example, the two-way table from example 1, and I'm dividing that input by the total numbers. So if we continue that same pattern, we go through here. Nothing is a 13 over 30, which is equal to 0.43. And then our last one is 4 divided by 20, which is 0.20. So if we look, our totals, remember, we had 30 over 30, which is equal to 1. And we had, switch that up. Let's erase that. That should go on the top one, because our vanilla was 30. And then our chocolate was 20. So this is our frequency table if we were going for the rows. In your frequency table, you don't need to show the fraction. You just need to go through and show the decimals. So from now on, I will tell you how I got those decimals, but you just need to write the decimals in the squares or in the different cells. So if we look at number 3, to create a relative frequency two-way table for the columns, you need to divide each number in that column by the total in that column. So our totals are 16, 17, and 17. So I'm taking those initial values that we found in example 1, And I'm going to divide that by 16 in the sprinkles column, 17 in the M&Ms column, and 17 in the nothing column. So if I look at the vanilla row, I have 9 divided by 16, which would give me 0.56. 8 divided by 17, which gives me 0.47. And 13 divided by 17, which is 0.76. And then for chocolate, I'm going to be taking those values. 7 divided by 16 is 0.44. 9 divided by 17 is 0.53. 4 divided by 17 is 0.24. And then if we look, all of our totals should add up to 1. Because we have 16 divided by 16, 17 divided by 17, and 17 divided by 17. So this is the relative frequency table for our columns, so in terms of the toppings. Remember, if we compare that to number 2, remember that your columns go up and down. So number 3 was using the toppings. And number 2 was the ice cream. So we were finding the relative frequency according to ice cream in number 2, and the relative frequency according to the toppings in number 3. The last example is using the percents, which is the total number of students. If we look at how many students were surveyed in example 1, we had our total being 50. So that 50 divided by 50, that's going to equal 1.00. So with relative frequency tables, you're going to be looking at decimals or percents, okay? When we're doing these percents here, we take, again, the total number of students, and that was 50. Let's make sure you can see that. 50. So I'm going to work my way down in columns. So sprinkles would be, sprinkles and vanilla were 9 out of 50, which is 18%. Chocolate and sprinkles were 7 out of 50, which is 14%. So the total, if I added those up, was 16 out of 50, which would be 32%. M&Ms for vanilla, it was 8 out of 50, which would be 16%. Chocolate and M&Ms were 9 out of 50, which would be 18%. And the total for M&Ms was 17 out of 50, which is 34%. Lastly, if we look at the nothing column, we had vanilla and nothing was 13 out of 50, which is 26%. Chocolate and nothing was 4 out of 50, which is 8%. And nothing was also 17 out of 50, which is 34%. Now our last is the total. The total number of vanilla was 30 out of 50, so that was 60%. And chocolate was 20 out of 50, which is 40%. So in this data set here, this is our relative frequency to a table with percents. So we could say that, again, using the relative frequency based on our percentages, we could make and draw some of the same conclusions that we did in example number 1. Let's go ahead and see how we can use conditional probability with the two-way tables. So we're going to go through one main example here that has multiple parts for conditional probability. So the problem here states that the table shows sales at a car dealership, and it wants us to use the table to answer the following questions. So if we look, we have car sales, and that's our main topic. We have domestic, which is made in the U.S., and then foreign, which is made outside of the U.S. And then we have the prices along here, 15,000 or less or more than 15,000. So the first thing, the question that it asks us is how many domestic cars were sold? So if I look here, I look at the domestic column, and it says 15 plus 8. So 15 plus 8 is 23 cars. Then in letter B, it says how many foreign cars were sold. So I'm going to look in the foreign column, and that has 11 plus 12. And 11 plus 12 is also 23. So both types of cars are split evenly. Both have 23. Now, letter C, let's scroll up a little bit. Letter C says how many cars were sold for 15,000 or less. So in my chart, I need to now look at the columns. So 15,000 or less is the first column. If we add that up, it's going to be 15 plus 11, which is 26. So there were 26 cars sold for $15,000 or less. And the last thing that we're going to do is we're going to look at how many cars were sold for more than 15,000. That's that second column. When we look at that, we have 8 plus 12. So that's 20 cars. And remember, all of these here are in terms of cars. So now we can talk about conditional probability, because all of these totals are helpful for that. So to find a conditional probability, like P domestic given $15,000 or less, we show the following. But remember here, before we go ahead and answer this question, I told you we were going to talk about this notation a little bit more. So if we look over here, we have P domestic, and then this up and down line, and then it says 15,000 or less, right? This line here means given. So it is saying that after it, so this following statement, that limits our sample space. And we'll go through a couple of examples here. So if we look here at P domestic given $15,000 or less, that is the probability that the car is domestic given it costs less than $15,000. So your first step is always to determine the sample space. That means our total, what our denominator is going to be. So if we look here in this question, we need to find the given. And the given in this case was $15,000 or less. So if I look up here, $15,000 or less is letter C. So my sample space for this case is going to be 26. And that's going to be my denominator. So if that's going to be my denominator out of 26, then my numerator is going to be what I find in that first part, so the number of domestic. So given that it's $15,000 or less, so given that the sample size is 26, how many of those are going to be domestic? So again, we can also look at our chart as opposed to just looking at the numbers. When we look at our chart and it says given that it is that 15,000 or less, that means I'm looking in this blue column. It's giving us that sample space. All right, and then it asks us for domestic, given that. So if we look for domestic, that's my green thing. So my numerator is going to be 15 in this case because in that column, domestic is 15. So my conditional probability is 15 out of 26. All right, you can give it to me as a fraction, or if you want to simplify it in your calculator and give it to me as a decimal, that's fine too. But I'd say for this practice and this walkthrough, give it to me as a fraction. So if we look down here, we have a couple other probabilities. So the first one, it says, what is P, or the probability of the car being foreign given that it's $15,000 or less? So again, that $15,000 or less is that 26. We talked about that in the example above. However, if we look at the chart, if it's foreign, that's 11. So we looked and we completely eliminated this side of the chart. We don't need it because we're only concerned about this 15,000 or less. So if we go down, again, like I said, given that it's $15,000 or less, we know that the foreign number is 11. So my conditional probability is 11 over 26. Now, it looks like the opposite down here. It says, what is the probability of $15,000 or less given that it's foreign? So this one, if we look up at our two-way table, it's saying given that it's foreign. So it is asking us to look here at the foreign row. And if we're looking at that foreign row, the total foreign cars is 23. So 23 is going to be our denominator. And then in that row, if we look at it, we see that we have $15,000 or less is going to be 11. Because given that it's foreign, there's $15,000 or less. So if we look here, in this one, we have 11 over 23 as our conditional probability. This last question asks if the probabilities are the same. Is 11 over 26 equal to 11 over 23? And the correct answer is no, it's not. The reason why we'd say no, they are not the same, because they have different sample sizes. And remember, sample sizes, this term here, is just a fancy word for our denominator in conditional probability. So 23 and 26 are my sample sizes. Because those are not the same value, they are not the same probability. They will not give us the same percent. Now you guys have some example problems to go ahead and try. You have, let's see, 1, 2, 3 of them that deal with relative frequency, an example of each, and then you have for number 4, you have the conditional probability. So you have 4 different example problems to be doing. Those are to be done on your own, and then please go ahead and check it with a teacher for the correct answers to make sure that you are ready to move on to your practice. This is the end of the Cycle 4 walkthrough. Go ahead and get started on the on your own problems.